Hello everyone and welcome! Today, we're diving into the world of software testing, specifically exploring basis path testing. This is a fundamental concept that every developer should understand. It's a key technique in software development, ensuring the reliability and robustness of our applications. So, why test software in the first place? Because even if your code works perfectly for you under ideal conditions, unexpected inputs, unusual user actions, or unforeseen environmental factors from others can quickly reveal hidden bugs and vulnerabilities. Testing is our essential safety net, diligently catching potential issues and defects before they impact our end users. Early bug detection not only saves valuable time and resources, but also saves money and, crucially, protects your professional reputation and the integrity of your product. There are, of course, many different ways to approach software testing, but white box testing stands out as a particularly insightful method because it directly examines the code's internal workings, its structure, and its logic. Basis path testing, a specific and powerful type of white box testing, meticulously ensures that we thoroughly check all critical decision points and branching paths within our code. Learning and applying this method helps you think critically about your code, forcing you to carefully consider every possible execution path and potential outcome, and ultimately helps you become a more disciplined and effective developer. It moves you away from relying on ad hoc or random checks and guides you towards a more logical, systematic, and comprehensive approach to ensuring software quality. So, what exactly is basis path testing? It's a fundamental technique in software testing, but what does it really mean? Let's break it down. It's a method to ensure in a systematic way, every unique logical path in your code from start to finish is tested at least once. This helps catch errors that might only occur in specific scenarios. Think of your code as a map, a complex network of roads and intersections. Basis path testing makes sure you travel every essential road, ensuring no critical route is overlooked. It's about comprehensive coverage. The first concept to grasp is the control flow graph, CFG. It's a diagram showing how your code flows, the sequence of operations, with nodes for statements, representing individual lines or blocks of code, and arrows for control, indicating the order in which these statements are executed. When your code makes a decision using if or else statements, for example, the graph splits, creating branches that represent different possible outcomes, revealing different paths, each representing a unique execution sequence. Next is cyclomatic complexity, a key metric in basis path testing. A number that tells you how many independent paths exist, providing a measure of the code's complexity based on your code's decisions. The more decisions, the higher the complexity. If your complexity is 4, meaning there are 4 independent paths, you need 4 unique tests, each designed to cover one of those paths. An independent path is any route through the code, from the entry point to the exit point, that introduces at least one new decision or statement, something not covered by previous paths. By testing all these paths, ensuring each one is executed at least once, you ensure every logical decision is covered, providing a high level of confidence in your code's reliability. This gives you confidence, knowing you've addressed all critical execution scenarios, that your code is thoroughly tested, and more likely to function as expected in real-world situations. Let's break down basis path testing step by step. It's a structured approach to ensure thorough testing of your code, focusing on covering every independent path within the program's logic. This method helps in identifying potential issues and vulnerabilities that might be missed by simpler testing strategies. First, draw a control flow graph, CFG, of your code. The CFG visually represents the flow of execution, making it easier to understand the program's structure and identify potential paths. This graph serves as the foundation for basis path testing. Each statement is a node. Think of each node as a distinct action or step within your code's execution. These nodes are the building blocks of your control flow graph, and arrows show the flow. These arrows, also known as edges, indicate the sequence in which the nodes are executed. They illustrate how the program moves from one statement to another. Decision points like if or while, these are crucial points in your code where the execution path can diverge based on certain conditions. Create branches in the graph. Each possible outcome of a decision point leads to a different branch, representing a unique execution path. Next, calculate cyclomatic complexity. This metric provides a quantitative measure of the program's complexity, indicating the number of independent paths that need to be tested. VG =e n plus 2, where e is edges and n is nodes. This simple formula allows you to determine the minimum number of tests required to cover all independent paths in your code. This number tells you how many independent paths you need to test. It's the key to ensuring comprehensive coverage of your code's logic. Now identify those paths. Carefully examine your control flow graph to pinpoint the unique routes through your code. By tracing unique routes from start to end, follow each path from the beginning of the program to its termination point, changing at least one decision each time. This ensures that each path is truly independent and tests a different aspect of your code's logic. For example, a function checking if x is positive. This is a simple yet illustrative example to demonstrate the principles of basis path testing. Has two paths, one for x, 0, one for x, r0. The CFG would show a decision node and two outcomes. This visually represents the branching logic of the if statement. Cyclomatic complexity here is 2, so you need two tests. One test case should cover the scenario where x is greater than 0, and the other should cover the scenario where x is less than or equal to 0. This process ensures you cover all logic branches. By testing each independent path, you gain confidence in the correctness and reliability of your code. It's a systematic way to catch hidden bugs. Basis path testing helps you uncover errors that might be lurking in less frequently executed parts of your code. Once you've identified independent paths, turn them into test cases. Each test case uses specific inputs to force the code down a particular path, with an expected output. For our positive number example, path 1 uses x equals sign 10, expecting positive. Path 2 uses x equals sign -5 or x equals sign 0, expecting not positive. Run your code with these inputs and check if the outputs match. This confirms both branches of your logic work as intended. Basis path testing guarantees you're not guessing. You're systematically covering every decision. It's a minimal set of tests for maximum coverage. This approach catches bugs in less obvious parts of your code. It ensures your software is reliable before release. As you use basis path testing, watch for common mistakes. Don't misinterpret loops in your control flow graph. They add complexity. Avoid testing only the happy path. Edge cases matter. Keep functions small. High cyclomatic complexity means your code is too complex and harder to test. If complexity is high, refactor into simpler pieces. Collaborate. Have someone review your graphs and paths to catch missed logic. Basis path testing proves you've tested all logical constructs, which is valuable in both school and professional projects. Mastering this method helps you write cleaner, more maintainable code. It's a tool for building software that works reliably every time.